Good morning to all. Today we are going to discuss about the topic coordinate system in GIS and information system. The course outcome of the coordinated system is explain the fundamental concept of GIS. So it will be interlinked with PO1 and PO5, then PSO1. So finally, the course outcome of this today topic is explain the fundamental concept of GIS. The coordinate system. Coordinate system is a reference system for identifying a location on the curved surface of the earth. Location on the earth's surface are measured in angular units from the center of the earth relative to two planes. The plane defined by the equator and the plane defined by the prime meridian which crosses Greenwich, England. A location is therefore defined by two values, a latitude values and a longitudinal values. Coordinate system for Chennai 13.0827 degree north, 80.2707 degree in east. Coordinate systems for Canada 58.5304 degree north, 106.3468 degree west. So it is a unique feature, it is a unique identify number each and every places in the earth. So location on the earth's surface are measured in angular unit from the center of the earth relative to two plane. The plane defined by the equator like latitude value, the plane defined by the prime meridian that is called longitudinal value. Yeah, map projection bridge the two types of coordinate system, x and y coordinates. The process of projection transform the earth surface to a plane and the outcome is a map projection ready to be used for a projected coordinate system. The coordinate system, so see the equator based, the degree minutes second based, we can separate the each and every places. So this is the prime meridian, the south pole, north pole. So that is the equator base. This is the north, south, east. This is right from the west. So see the picture represent very clearly like latitude, then longitude. So see the prime meridian in equator based, north pole in equator, the angle based. The angular measures of longitude and latitude may be expressed in degree, minutes, seconds, decimal degrees, or radians. Like given that 1 degree equals 60 minutes and 1 minutes equal to 60 seconds, we can convert between decimal like a degree means second and decimal degree. For example, a latitude value of 45 degree 52 second 30 52 minutes 30 second that would be equal to 45.875 degree, like 45 plus 52 divided by 60 plus 30 divided by 3600. That radians are typically used in computer program. 1 radian equal 57.2958 degree and 1 degree equal to 0.01745 radian. So the datum, the mammoth collection of monument location in the late 80s, the researchers installed brass or aluminum disc at each reference location. Each monument locations was connected using mathematical technique like triangulation. In NAD27, North American Datum of 1927, it is a network of standardized horizontal position on North America. A researcher gathered approximately 26,000 stations in the United States and Canada. At each station, surveyors collected latitude and longitude coordinates. The NAD83 researcher benchmark approximately 250,000 stations. The set of horizontal position formed the basis for the North American datum of 1983, NAD83. In 1983, the NAD27 datum was eventually replaced with NAD83. It's provide latitude and longitude and some height information. The WGS 84 unifying a global ellipsoid model with GPS. The radio waves transmitted by GPS satellites enabled extremely precise Earth measurement across continue and occasions and oceans. The map projection. A map projection transforms the geographic coordinates on an ellipsoid into locations on a plane. The outcome of this transformation process is a systematic arrangement of parallel and meridians on a flat surface representing the geographic coordinate system. Three types of map projections are cylindrical, conic, and then azimuthal. The map projection, the simple case, then second case. So see the first one, the conic and cylindrical and then azimuthal. The cylindrical map projection, straight coordinate lines with horizontal parallel crossing meridian at right angles. The conic map projection, these maps are defined by the cone constant which detach the angular distance between meridians. Then azimuthal map projection. The common map projections are Robinson's projection, transverse Mercator projection, Lambert conformal conic, space obligate Mercators. So the Robinson projection, world maps look right there rather than measure precisely. Used in many popular maps such as the Rand MC Nellis series from the 1960s and the National Geographic Society since 1988. Transfer Mercator projection. The transfer Mercator projection is widely used around the world and work especially well for mapping areas smaller than a few degree longitudinal such as a state or country. The Lambert comfort conic. So see the picture representation. The projection is one of the best to use for middle latitude and it's often used for heuristical chart, habitacer and maps with wide east-west extents. So the two standard parallel selected by map makers. The space obligate mercators. This map projection was developed fairly recently in 1976 for the specific purpose of mapping up imagery from an orbiting satellite around the ellipsoid Earth. So the GIS and information system. In a GIS, users connect data with geography. Geographic information system really comes down to just four simple ideas: create, manage, analyze, display. Like create a geographic data, manage it, analyze it, and display it on a map. It's really hard to visualize the location of latitude and longitude coordinates from a spreadsheet. So see in a particular area what is the latitude and longitude, how it will be mentioned in each and every area. So but when user and these positions on a map, it's like magic to the reader. So GIS and information architecture. The architecture like a structure of GIS can be split into three main components: a user interface client, an application engineer, and our server, a database. So see the user interface client allows the user to interact and use GIS tools through a geographic user interface. Then an application engine server, the collection of tools available for the user to manipulate and analyze GIS data. A database, a data stored as file or web services and the associated database management software. So see the user interface, application server, then database. From the user interface like Google Map, Big Map, like ArcGIS desktop, Google Earth, UDIG desktop, QGIS. This all those things user interface map. Then application server, Geo server, Geo web cache, integrated Geo media, Autodesk map guide, Iradas Upflow, RJ server. Then database, PostGIS, PostgreSQL, MySQL with Spatial, IBM Database 2, Oracle Spatial, Microsoft SQL Server, ArcGIS Server, Arc SDG. The assessment of this session: GIS is dash and dash technology. Then GIS, remote sensing and GPS technologies are. So kindly make an assessment and find the answer. So this is are the reference material. Thank you.